Hello class, welcome back to the third video of this series. Okay, and last time we were looking at three examples, or we got started looking at three examples. We completed the first one, and the first one was we were trying to figure out how to use flat map, or what is a scenario where flat map might be useful. Okay. And the problem is we want to find all pairs of numbers from 1 to 3. Okay, so our set is S equals 1 to 3, or a list is 1 to 3, and we want all pairs of numbers from this set. Okay, 1 1 1 2 1 3 2 1 2 2 2 3 3 1 3 2 3 3. We want why some problem dictates that we had to generate this. Okay. And we were looking at taking the 1 to 3 as a range or a sequence object here, okay, and then applying a map function to it in a nested manner. Okay, so we had a map, and then we had the function x arrow, and then the output is this, which itself is a map function 1 to 3, which also takes the 1 to 3, the other 1 to 3, and maps. And then for each value y in this, now x would be a value in the first 1 to 3, y would be the value in the second 1 to 3. And all it does is that puts them together in a tuple, okay, tuple, x comma y. That's all, okay. And this map would generate the answer, but it doesn't come in the form or format we want it, okay. It comes as a vector of vector, okay, vector of 3 vectors, and each vector contains the set of answers we have. The first one has 1 comma 1 1 2 1 3. Second is 2 1 2 2 2 3, and 3. But we wanted to flatten this, okay, and so you could take the output and flatten it with a dot flatten, okay, or you can use the combined operator flat map, okay, which will take the do all of this, okay, and then at the end flatten it, okay. So that's all that is, okay. And when you do that, you get all the pairs here: 1 1 1 2 1 3 2 1 2 2 2 3 as a sequence, okay. And then you can do for something on this if you want, okay. But anyway, that was the idea there. Let's look at two more examples, okay. Maybe, or if you want just to be, we can actually put these in different cells. It's always a good idea to put them in different cells, and then let's put this one out here, put it here. Okay, so let's look at this next example, scalar product, okay. This is from math, some algebra, some kind of algebra, linear algebra, or maybe even before that, I don't know. Anyway, we are given two vectors, xs and ys, okay, which are the parameters here, okay. Both of them are vectors of double, that means they contain numbers, okay. And what I want is the scalar product of these two vectors, okay. Scalar product is defined simply as, you can take the example here, 1 2 3 is the first vector, 4 5 6 is the other vector, okay. Now for a scalar product to work, both these vectors must have the same number of elements, all right. So and the answer is a single number, as you can see in the return type, it's a double, okay. And the single number is obtained as follows. The first item here is multiplied by the first item there, okay, 1 times 4. And then the second item is multiplied by the second item there, 2 times 5, and the third 3 times 6. Okay, so the corresponding items are multiplied, and then the values are summed or added up. Okay, so 1 times 4 plus 2 times 5 plus 3 times 6. Okay, so that's what will happen here, and one number will come as the answer. Okay, all right. So that's what the scalar product is, and let's see how we write the code for that in Scala. Here's a one-liner for that. Okay. By the way, Scala and functional programming is, the general idea is that if you write more than one line of code for anything, that means something wrong, okay? I'm not just kidding, but few lines of code is what I'm saying, okay? Most of the time, you can get the job done in 3, 4, 5 lines of code, or one mostly, and so on, okay? So let's see how this works, okay? So we have xs, which is a vector, ys, which is a vector, and when we do a zip, what happens? You get a we didn't see an example of this, but you'll get a vector or a sequence, okay, probably a vector, of pairs where the first item here and the first item there are combined together. So the 1 and the 4 will be combined together into a tuple, 1 comma 4, and then 2 comma 5 in the next item in that zip, okay, and then the third item will be 3 comma 6. Okay, so this now on the left side of the map is actually a list or a sequence of pairs of numbers, okay, the corresponding pairs from x's and y's, okay. And to each pair, we apply this function, okay? And what is that function? It takes a pair, or x, or whatever you want to call it, okay? I just call it pair. Pair would be one of those pairs, and returns pair dot underscore 1 times pair dot underscore 2. So that will multiply the two numbers, okay? And then what it'll do is it'll produce a list of the products, okay? And then finally, we to get the scalar product, we want to do a sum of those list of products, right? So when you do a dot sum on that list, you'll get the answer, okay? So you can see that we are just composing one function after another function. So in this itself, there's a whole bunch of functions happening, okay? A zip is happening, a map is happening, a sum is happening, a times is happening inside this, and then an anonymous lambda function is happening here. These two lines is the epitome of functional programming, okay? Epitome of functional programming, okay? One line of code, I mean 2 lines. One is the signature line and the one line of code, which is composing a whole bunch of functions built in and non-built in and everything else, and also a higher order function and so on, okay? So this is really why we are learning functional programming, to write this type of code, okay? And here's a run of this, so you should get 32, okay? 4 plus 20, is that right? 1 times 4 is 4, 2 times 5 is 10, 2 times 5 is 10, so 4 plus 10 is 14, and then 3 times 6 is 18, so 14 plus 18 is 32, so that's the correct answer, okay? Now let's do the third one, which is third example, prime number check, okay? So we want to write a function def is prime, n is an integer, so a positive integer, let's say, comes to us, okay? And we want to return true or false. True if this is prime and false otherwise, okay? So prime number check is that it should be divisible. It should not be divisible by any number less than it, right? That's a naive way of determining prime. We are doing a naive algorithm here, okay? So 2 until n, what would be that range? So it'll be 2, 3, 4, 5, 6 up till n minus 1, right? It doesn't include n because until stops one before, okay? All right, so this is that sequence. And then for all means this predicate which is written there would be verified true for each one of those, okay? And if that is true, then the whole thing is true, right? If for each one of these items this is true, then that's true. And what is this? This is a predicate, okay? Predicate means it's a function. Predicate is nothing but a function which returns a true-false value, okay? D is input to that function, so which will be one of these numbers, okay? And output is n div d not equal to 0. Or should this be equal to 0? Okay? No, not equal to 0, right? Because when you divide, mod, when you find the remainder, n mod t, not div t, but mod t. So when you take the n and the number which you're checking, and then you do a divide by d and find the remainder, okay? And you find a remainder which is not 0, that means that's good. It is not divisible by this, right? Yeah. So for all numbers d, if n div d, n mod d is not equal to 0, that means it will be a prime, right? So this for all is important because the number must be divisible by, should not be divisible by each of the numbers below it, correct? Now, if you wanted to, you could have done n div 2 here, okay, correct? Because that after halfway, you don't have to check that, okay? So maybe I'll throw that in and let's see what happens here on this cell, okay? Yep. So it checks is prime 13 true and is prime 15 false, okay? N div 2 is probably better than n, okay? Both would work, but you can stop at n div 2 and get the answer. All right. So there are 3 examples here we showed. One for the generating this sequence of tuples, 1, 1, 1, 2, 1, 3, and so on. And the other one was for the scalar product, and the other for the is prime, which made use of some of these other functions which we looked at, okay, other methods on sequences, okay. All right, now we are going to do one particular example. We're going to solve a particular problem, okay, a little bit of artificially determined problem, okay. So, but it has some points to illustrate, and that's why we discuss this problem, okay. It's called the nested sequence example, and we will use the actual this index sequence 1, 1, 1, 2, 1, 3. That idea here in this problem, okay. All right, so this is the problem statement here. Given a positive integer n, okay, like 7 or something like that, find all pairs of positive integers I and j which satisfies these two properties, okay, or this property. So you want to find all possible pairs of integers, positive integers, okay, no negative, okay, no zero, okay, one or more, okay, so that we are dealing, but n is given to us, okay. And what are the pairs I and j? I and j must be between 1 and n, not including n, so it should stop at n minus 1. So I and j must be between 1 and n, okay, until n, and j must be less than I. So the second item in the pair, okay, must be less than the first item in the pair, okay. All right, there are many such. So for example, if 7 is such a number, and if n is 7, then 5 comma 2 would be a valid pair, right? Because 5 is the I, 2 is the j, and 2 is less than 5, right? But there's an additional condition, and the condition is that the I plus j must be prime number, okay? So we want all pairs of positive integers I and j which satisfies that condition, that first of all, both I and j are less than n, strictly less than n, and also j is less than I, and I plus j is prime. So there are 3 conditions there, you see, or 4. I is less than n, j is less than n, I plus j is prime, and j is less than I, okay? So there are 4 conditions there, okay, for I and j. Actually 5, where all numbers are more than 0, okay? Got it? So those are the pairs of, and n is given to us, okay? So that's what we want to do. So here's a sample n equals 7, then this is the correct answer, okay? These are all the pairs of I and j where I and j are more than 0, less than 7, and I is more than j, and I plus j is prime, okay? Whole bunch of conditions, okay? So you can see 2 plus 1 is 3. By the way, first of all, check whether j is less than I. The second item is less than the first in all of them, okay? That's true. And then when you add these two, 3 plus 2, 5 is a prime number, 6 comma 5 is 11, which is a prime, and so on. So they're all prime, and all the numbers are more than 0, okay? All right, and all of them are less than 7 also, okay? So that's the set of pairs, or a sequence of pairs in the output, okay? So the function is takes one number n as input and generates this sequence as output, okay? Here's a solution. Actually, this is not all of the solution, but it is a solution working in steps, okay? All right, so let's let's take n equals 7, okay? And this expression we've just seen before, okay? We saw with a flat, okay, flat map, but I guess we're doing it in 2 separate steps, or these two could be combined into one step. Yeah, it's actually combined in the next step here. Actually, let's go ahead and, yeah, this one is illustrating the flattened part, okay, which we've already illustrated before, so I'm going to skip that cell. I'm going to come here, okay? All right, so this is the first expression, okay? So what is this going to do is it's going to generate all the pairs between 1 and n, okay, such that the second item in the pair is less than the first item. So that's all, okay? So it's not going to check for prime number, the I plus j prime, okay? So that will delay to later, okay? So we're going to solve the problem in 2 steps. First step is to generate all the pairs which satisfy the initial conditions, that is, both the numbers I and j are more than 0, both of them are less than n, okay, and the second number j is less than the first number, okay? Those three or 4 conditions, okay? That's all we are worried about. We're not worried about the prime check. We'll do that separately, okay? Okay, and here's the expression which does that, okay? Here's the one expression, val pairs equals. Now when we say 1 until n, we are automatically satisfying the condition that all the numbers are more than 0 and less than n, correct? Because 1 means starting at 1, and until n means not including n. So that way we enforce those 2 conditions, greater than 0 and less than n, okay? Same thing here, you see, we will do the same thing on the second part. And we do the flat map instead of map so that we can flatten and get all pairs, okay? And this is slightly modified than before. Instead of going from 1 to n, remember in the previous case 1 to 3 and 1 to 3 is what we did, okay? We'll say 1 until I. So this is like the inner for loop which is stopping at I. And I'm sure you've done things like this in your 1301, 1302 for nested for loops. Okay, so it's somewhat same idea here. So by stopping at I instead of n, we would actually get this value or this sequence of values always less than I. Okay, so the j, which because this will be the value of j. Okay, right? Because we are mapping with this function j. J will take a value from here, and I will take a value from the first until. Okay, so this way we are assuring that the j will be less than I, and all we're doing is we are clubbing I and j together into a pair. Okay, you see that? All right, so this is a very minor modification of the previous solution. The only thing is instead of this n, we change it to I. That's all. Rest is exactly the same. Okay, so we will get this. If you want, you can change this to n, and n equals 7 in the previous cell, by the way, right? And that carries over here. Okay, n equals 7. That carries over to this cell. Okay, so when I run this, oh, I guess it doesn't know the n. Okay, sometimes it carries over, sometimes it doesn't. Okay, yeah. Okay, let's run this. Okay. Okay, so so this is exactly same as before. 1 until n are in both places. So you get 1 1 1 2 1 3 1 6, and then all the way up to 7 6 6. Right? All the pairs. Okay. But when I change this to I, then that's what we want, right? Because then 1 1 is not there because second number has to be less than the first. 2 1 is the first pair, and then 3 1 3 2, then 4 1 4 2 4 3. We don't go to 4 4 4 5 and so on, right? Because those are the I must be more than j. And then 5 1 5 2 5 3 5 4, and 6 1 6 2 6 3 6 4 6 5. Okay, so you get the right pairs. Okay, so that's the part of the solution, the first line here. Okay, and then now what we do is we take the pairs and filter. Okay, and so hopefully the is prime function is still active. Okay, and also the pairs is available here in this cell. So we filter pair arrow. So this is the predicate is prime pair dot underscore 1 plus pair dot underscore 2. So we have to add the two numbers and check whether it's a prime, right? That's what the condition was in the problem. Okay, so let me run this cell, and I do get the correct answer. See, 2 1 3 1 3 2 and so on. Okay, there you go. That's the end of this problem. Okay, solution. So it's a two-line solution. Now if you want to put all of them together into one cell, okay, let me put all of this code and maybe even write a function. Yeah, let's write that in the form of a function. Okay, so it'll be a two-liner. Okay, so I can put it after this cell. Okay, after this cell, so that plus gives me an empty cell. Okay, so def let's see, I don't know what to call this, p yeah, prime pair, right? Prime pairs. Okay, and yeah, it's the input, and output is pairs. Yeah, list, or actually it comes as an index sequence, right? Or let's say we don't give the data type here. Let's see whether it can figure out. Otherwise we have to come back and equals. Okay, since it is, I guess we can put it both in one line. Okay, we'll have this. If you want, you can put a block. Okay, it may get confusing, right? If you put all of this in one line. Okay, but at least this long one. Okay, so right, so this is what we want. Okay, and then we want to call prime pair with 7, right? Yeah, so here's the prime pair function, okay, which takes n as input and returns a pair of numbers. Now the only thing missing is the return data type. Let's see whether that works here. Okay, yeah, Scala is pretty smart to figure out the return type, and actually the return type is here. Okay, index sequence. Let me see if I can just give, let's say, q sequence of int comma int, right? So that's really what we want to return. Yep, pretty good. Okay, yeah, so that's the return type, sequence of pairs of integers. Okay, and that's here, and these are the two steps. First is getting all the pairs, and then the filtering it. Now, if you want, you could have done a dot filter at the end and got all in one line, but it gets too long, so maybe put a block and do that. Okay. All right. So that's really what that example is. Okay. Now, this previous problem. I mean, this solution is nice, functional, and so on and so forth, but there's a lot of things happening in these two lines, right? Or if you combine the two into one line, there's a lot of things happening. There's an until here, there's a flat map there, there's a function here, a nested map there, and there's another until here. There's another, there are two anonymous functions here. There's a third one, a predicate, third anonymous function, and there's a filter, and then is prime, and a whole bunch of stuff happening here, right? Good and bad. Good in the sense that, yeah, it's functional, and actually it's robust in the sense that if each one of those individual things are correct, then the whole thing should be correct, right? You put them all together properly, okay, hopefully, okay. But I think that there is a little better way to do this in functional languages, and that's why this new structure or new construct we had to learn. It's called the for comprehensions, okay. These are fine. This is actually a nice, neat syntactic notion, which is very powerful both in Python as well as in Scala and so on. So, and also both this for comprehension works very well with functional programming. So let's learn this one, okay? So in the previous example problem, the prime pair problem, okay, we got a solution and we're happy with it and it's functional and so on and so forth, but there were too many things which were getting mixed and matched there, okay? Right? But it got a little hard to understand which was happening first. I mean, if you dig deeper, you can understand it, but there's a whole bunch of things happening and can complicate matters. Is there a nice, cleaner way to write this solution? Is the question. And the answer is yes, if you know for comprehensions. Okay, so let's quickly learn what for comprehensions are. For comprehensions is a little higher level construct which allows you to do in a very logical manner many of the things we just did. Okay, so as to say, Scala's for comprehensions come to the rescue. Okay, so let's understand the syntax of this. Okay, and we'll do this with that case class, or actually here we're doing regular class. Okay, although this, this is a regular class. Now, I really don't want you to become experts on object-oriented programming in Scala. Okay, but once in a while there is an example which is object-oriented. Okay, so this is how you define a class in object-oriented Scala. Okay, just like in Java, you say Scala. Name of the class, and then of course you don't give the instance variables here. We actually define the instance variables inside. Okay, but in Scala you have to give the instance variables up there. Okay, n and a are the instance variables. Oh, excuse me, no, sorry, those are not the instance variables. The instance variables are defined inside, but these are the parameters to the constructor. Okay, so n and a are the two values which will be used as input to the constructor. Okay, and those values are used here to initialize the instance variables name and age. Okay. So you can actually see that this is how you do it in normal object-oriented, but when you use case classes, you can actually do a lot of shortcuts, okay? All right, so we are doing pure object-oriented programming here, okay, in Scala. Anyway, there are two instance variables, name and age, and we assign n and a as the initial values. And this is how you will construct a new object, S1 and S2. S1 is new student and provide the two values for n and a, Smith and 35, okay? So we got two objects, S1 and S2. This is not a case class object, but it is a pure object, okay, and pure classes in Scala. Okay, and then also we created a list of students, S1 and S2. So students is a list of two students, and the two students have those instance variables, Jones 25 and Smith and 25. Okay, so now let's say that I have a list. So I just a list of students here, but this would work with anything. Okay. And let's say I want to generate a list of just the names of the students. Okay, so it's almost like in SQL. You'll say select name from student. Okay, then you get all the names of the students, right? So that's really what we want to do here. Okay, and that's what this for comprehension allows us to do. We'll look at the exact syntax, but here's an example usage of that. Okay, yeah, the for keyword. This is not a for loop in some sense, okay, although you can think of it like a for loop. Okay, so this is technically not a for loop in the traditional sense, but it is a for loop in the functional sense. Okay, so for, and this thing is called a generator, and this is called a predicate. Okay, I think they're called predicates or conditions or something like that. So you have a generator, one generator. Okay, actually you can have more than one, but in this case only one generator. Okay, generator is basically a sequence or a set or something like that, and then you iterate through that with the variable s. Okay, so here s is a single student, students is a list of students. Okay, and we had to say arrow in between, backward arrow. Okay, s less than minus and then that. Okay, so that's how you write a generator. Okay, and the condition is you can use this generator variable s in the condition. So s is a single student, and s dot age would refer to the age. Oh, by the way, this query is not just the select name from student, but it is select name from student where age greater than 30. Okay, so it's a pure SQL query. Okay, so if s dot age greater than 30, then yield is the output, yield, and then s dot name. So I want to print the s dot name. Okay, so this is almost like an SQL query in some sense, although we'll start writing examples which are nested and this and that and so on. It can get okay, but in some sense you can think of, if you're familiar with SQL, this looks like something like that. Okay, so anyway, what this does is that you can actually see it produced the answer here, Smith comes out as the answer. Okay, because what will happen is that you will generate all values for s, which will be s1 and s2, right? Because that's and then this condition is checked on each one of those s, and in this case 35 will be selected, right? Because this s2 will be true, but s1 will be false, this condition. And then yield s dot name means that's what comes in the output. Okay, and this output comes in a list. Okay, because generator may generate many items and a filter, so this is somewhat like a filter happening here. Okay, s dot age, and then this is the final answer which is coming. Okay, so this is how a for comprehension looks like. Okay, nice compact notation to do a set or a sequence operation on a sequence, and sort of if you keep the SQL querying back of your mind, this may sound a little easier for you to understand. Okay, all right. Let's look at the general syntax. Okay, and then we'll look at a few more examples. Okay. So this is the general syntax: for something, yield something. Okay, and what you put in the for, if it's a one-liner, you put it in parentheses. But if this s becomes more than one line, then you can put it inside braces. We'll see that example soon. Okay, so that it looks nice and clean. Okay, but what goes inside the s is a sequence of generators and filters. Oh, by the way, the second thing is called filter. Yeah. Generators or filters. So normally you'll see a bunch of generators and then a bunch of filters. Okay. And in the most simplest case, you'll see one generator and one filter. Okay, but in general, you can mix and match these things quite a bit. Okay, and what comes after the yield, by the way, for and yield are keywords, and then what comes after the e is the expression whose value will be accumulated into an iterator. Okay, returned by an iterator. I think this probably should be iterator object. Okay, yeah, iterable. Yeah, return as an iterable. So that's better. Okay, that's probably the right way to say that. Okay, where s is a sequence of generators and filters, and e is an expression whose value is returned as an iterable. Means you'll get a list or a sequence at the end of it. Okay, and this is the syntax for a generator: p arrow e. Okay, where p is a pattern. Okay, and e is an expression whose value is a collection. So on the right side must be a collection, and this is actually a pattern. And typically it's just a single variable. Okay, but sometimes you can actually have a tuple or something like that there. Okay, so it's a very powerful notation here for this for comprehension. Okay, and e is a expression, any expression, but must result in a collection. Okay, so right side is a collection, left side is a single element in the collection. And filter will be if something, where f is a Boolean expression or a predicate. Okay, and the sequence must start with the generator. So the first thing you have to write is a generator. You cannot start with the filter. And also you can put braces if it is going into multiple lines. Okay, all right. So now we know sort of the syntax for the for comprehension. Now here is the same example, the pairs example. Okay, the pairs example, the prime pairs example. Okay, using for comprehensions. Okay, here for, and then we are using the brace because we are writing in multiple lines what goes between that. Okay, but we could have used parentheses also, which will be fine. Okay, but normally you put braces if you have multiple lines and parentheses when you're in one line. Okay, and in yield we want to yield a bunch of pairs I and j, right? That's the pairs of numbers. Okay, and assuming n is given as a parameter, or n is known to us, I goes, so I ranges from 1 until n, right? And j ranges from 1 until I. So here are the two generators, okay, 1 and 2. And the j must be written after the I because it uses I, okay? You cannot exchange these two, okay? So I is I arrow, back arrow 1 until n is the first generator, okay, which generates values for I. And the second one is also a generator which generates the values for j, but the j depends on I, okay? And then there's a filter if is prime I plus j, okay? So we have three lines of code, but it's all part of this for comprehension, okay? It's all one, the whole thing is one line of code actually, written in multiple lines, okay? So you can see that it looks like more like a for loop, nested for loops or whatever. It looks much cleaner, okay? So this is how this works. And if is prime I plus j, then you yield it. Yield means in the output you produce that, otherwise you don't, okay? Now this whole thing would have worked if we had said n here and then introduce the condition here, j is less than I, and then you have to say and, I guess, okay? I think that would have given us the same answer as well. Yeah, gives us the same answer, okay? Got it? So here we are not worrying too much. Now, to make it a little bit more efficient, it's better to put that the way we had it here. Okay? This one is better, okay? A little bit more efficient, and also this is how naturally you do it. You see, if you want to generate for loops in your Java code, okay? All right, so that's an example of a usage of a for comprehension. Very powerful, okay? And we will look at a couple of examples here. Two more examples here, okay? Or actually one more, okay? This is the scalar product example, which we just saw, and we're going to do it with for comprehensions, okay? All right, so earlier we did map, and so on. We're going to flat map and so on, whatever it is, but we're going to use do for comprehension. So xs and ys are the two vectors inputs, okay? And we start with a for comprehension in which we have the generator xy arrow, xs zip ys. Remember, xs and ys, you zip them up, and then in the for comprehension you say x comma y is a sample element in the zip, okay? So that's your generator. There's no condition here or filter here, okay? So you can leave out the filters. So there's only one generator. So we'll look at all possible pairs of x and then call them xy, and then we yield x times y, right? And that will give us a list of the products of the corresponding items, and then the whole thing dot sum will give us the sum, okay? So there's another way, a little bit better, because we use for comprehension. Some of the things are hidden inside. The map and the flat maps are all hidden underneath, you see? That happens using the for loops implement, the for comprehension is implemented using maps underneath, okay? So we have hidden the map and the flat maps and so on, okay? So it looks much cleaner here, right? It's a little easier to understand than the previous solution, which did not use the for comprehension, okay? All right, so that's the end of this for comprehension. We may see one or two more examples of this, okay? All right, we are at 33 minutes, so I think I'm going to stop this. We have got sets to cover and one n-queens problem. So that, and then the last topic will be the dictionaries. Okay, so we have two more topics to cover. Hopefully in 2 videos we can cover those 2 topics, okay? 2 more videos, that is, okay. So this is the end of the video number 3.